Good morning, John. When we look out at other solar systems in our galaxy, the thing that captivates us the most is the potential of finding other Earth-like worlds. Rocky planets inside the habitable zone of their star. Not too close that the water would boil away, not so far away that all the water would be ice. But this is more a question of whether we could live there, less a question of whether there could be life there. But if we're talking conducive to life, we've got some problems. First, the places most conducive to life outside of Earth in our solar system are outside of the habitable zone. They are Enceladus and Europa, two ice moons of gas giants that both definitely have giant oceans of liquid water beneath their icy surfaces. The second problem is that we've actually got two planets in our solar system, Mars and Venus, that were probably habitable for a pretty long time. One of them, Mars, is in the habitable zone. The other, Venus, is not. Though admittedly, now neither of them are great candidates for human habitability. Mars, as you may have noticed, is not a verdant ball of life, and Venus is even worse. You could probably live longer on the surface of Mars without a spacesuit than you could live on the surface of Venus with one. Highs on Venus are like 900 degrees Celsius. That's enough to melt lead. So it makes a kind of sense that in our search for life in our solar system, we've focused on Mars. Not because it's the best candidate, though it's a fine candidate, but because it's just a lot easier to work with. But we have over the years noticed some weird things about Venus. Areas of its thick clouds that get dark for some reason that we can't explain, for example, which has led to people looking for how life might exist there. And here's the thing, if you move away from Venus's surface and towards space, well, they say it gets colder. Cold enough that steam condenses into droplets of water. The temperatures and pressures 40 to 60 kilometers above the surface of Venus are like Florida. Except for the part where the water droplets are highly concentrated sulfuric acid. Venus sucks! No life on Earth could live in water anything like that acidic. But life does sometimes find a way. The thought is that maybe some kind of microscopic life could live inside of these water droplets, and then as they eventually and inevitably fall toward the surface of Venus, those droplets evaporate, and those cells are then able to enter some kind of dormant spore stage until they get tossed back up into the nice part of the atmosphere again. And this is just guessing, but it means that maybe it's worth looking to see if maybe there are some chemicals in the atmosphere of Venus that we can't explain. And that's why it was a big deal this week when, among the rest of the world being an unforgivable mess, scientists announced that they'd found a seemingly impossibly high concentration of phosphine in the atmosphere of Venus. Phosphine is nasty stuff if you're a human, but it's okay for some microorganisms. They produce it as a waste product, specifically bacteria that don't use oxygen in their metabolism. And phosphine can't exist in the atmosphere of Venus very long. There are processes that would break it down pretty immediately, so it existing means something is creating it. Now, of course, there could be some unknown geochemical process that produces phosphine on Venus, and if so, just figuring that out would be a big deal. And there's a phrase that often comes up in the search for life on other planets: extraordinary claims require extraordinary evidence. And so if you're going to claim that life exists somewhere else in the solar system, we need the big proof, which the authors of this paper confirm would need to be an actual visit to the upper atmosphere of Venus. And I imagine that mission will happen in my lifetime, which is super exciting. But I actually don't think it's extraordinary to claim that there is life elsewhere in the universe, maybe not even in the solar system. Look, we've never found a way to duplicate the cascade of chemistry into life in the laboratory. But it's also definitely a thing that happened. And if a thing can happen once, it can happen again. It can probably happen again a lot. And so if it happened to happen on one of our next door neighbors, that would be extremely exciting, but maybe not as surprising as we might at first think.